ChatGPT, Claude, Gemini, the AI tools reshaping how we work, write, and reason are all powered by the same foundational technology, the large language model. An LLM is a neural network trained on vast quantities of text data to understand and generate human language with remarkable fluency and depth. These models learn the statistical patterns of language at a scale that produces emergent capabilities, abilities that were not explicitly programmed but arise naturally from scale. In this video, we explore what LLMs are, how they work, and where they are transforming real-world applications. Let us examine what makes large language models so powerful and why they represent a genuine inflection point in the history of artificial intelligence. 5 fundamental properties distinguish large language models from earlier approaches to natural language processing and explain their extraordinary capabilities. The defining characteristic of a large language model is its scale. Modern LLMs contain billions, sometimes hundreds of billions, of learnable parameters, which are numerical weights adjusted during training to encode patterns discovered in the training data. This sheer scale is what separates LLMs from earlier neural networks. Scale enables the model to capture not just surface-level word associations, but deep syntactic structure, factual knowledge, reasoning patterns, and stylistic nuance across an enormous range of domains and topics. The transformer architecture, introduced in the landmark 2017 paper, "Attention is All You Need," is the computational engine that makes LLMs possible. Unlike older recurrent networks that process text word by word, transformers process entire sequences simultaneously using a mechanism called self-attention. This parallel processing dramatically accelerates training and allows the model to capture long-range dependencies, understanding how the meaning of a word at the beginning of a long document relates to words thousands of tokens later. Before fine-tuning for specific tasks, LLMs undergo pre-training, an unsupervised learning phase in which the model is exposed to enormous, diverse text corpora. These corpora typically include books, scientific papers, websites, code repositories, and multilingual content. During pre-training, the model learns to predict the next token in a sequence, a simple objective that forces it to develop an extraordinarily rich internal representation of language, knowledge, and reasoning patterns across virtually every domain. A critical capability of modern LLMs is instruction following, the ability to understand and execute natural language instructions without requiring the user to have technical expertise. This capability is developed through fine-tuning on instruction response pairs and through reinforcement learning from human feedback. Instruction following transforms an LLM from a raw language model into a practical assistant that can draft emails, summarize documents, write code, answer questions, and perform complex reasoning tasks on demand. One of the most striking and scientifically significant properties of LLMs is the emergence of capabilities that were not explicitly trained. As models scale beyond certain thresholds, they spontaneously develop the ability to perform multi-step arithmetic, translate languages they were not specifically trained on, reason through novel logical problems, and generate coherent long-form arguments. These emergent capabilities are not fully understood theoretically, but are consistently observed empirically as model scale increases. 4 essential terms that every practitioner needs to understand when working with large language models. Pre-training is the foundational phase that gives an LLM its general intelligence. During pre-training, the model is exposed to trillions of tokens of text and trained to predict the next token at each step. This seemingly simple objective forces the model to learn grammar, facts, reasoning patterns, coding conventions, and the relationships between concepts across an enormous range of domains. Pre-training consumes the vast majority of the compute budget for a modern LLM, often millions of dollars of GPU time, and produces a general-purpose language model that can be adapted to specific tasks through fine-tuning. Fine-tuning takes a pre-trained LLM and refines it for a specific purpose or to improve its alignment with human preferences. Supervised fine-tuning trains the model on curated instruction response pairs, teaching it to follow instructions helpfully and accurately. Reinforcement learning from human feedback, or RLHF, uses human rankings of model outputs to further align the model's behavior with human values and preferences. Fine-tuning is what transforms a raw pre-trained model into a helpful assistant like ChatGPT or Claude. Inference is the production phase of an LLM's life cycle, the moment when the trained model is deployed and used to generate responses to real user inputs. During inference, the model performs a forward pass through all its layers, attending to the input tokens and generating output tokens one at a time in an autoregressive process. The computational cost of inference is significant. It requires powerful GPUs or TPUs and scales with the number of tokens generated. Optimizing inference latency and throughput is one of the central challenges of deploying LLMs at scale. Tokens are the atoms of text for an LLM. Rather than processing whole words, LLMs operate on subword units produced by a tokenization algorithm, such as byte pair encoding. A single English word might be 1 token, 2 tokens, or more, depending on its frequency and the model's vocabulary. The number of tokens in a prompt determines how much context the model can consider, a key constraint given that all models have a maximum context window. Understanding tokenization helps practitioners estimate API costs, manage context limits, and diagnose unexpected model behavior. Let us now look at how large language models are being deployed across industries to automate tasks, augment human work, and create entirely new capabilities. Large language models are being applied across a wide range of high-value use cases that were previously too expensive, too slow, or technically impossible to automate. Customer service is one of the highest impact application areas for LLMs. AI-powered agents can handle thousands of simultaneous customer queries, understand natural language questions about products, policies, and account details, escalate complex issues to human agents, and maintain conversational context across multi-turn dialogues. Organizations deploying LLM-based customer service report significant reductions in average handling time and cost per interaction, while maintaining or improving customer satisfaction scores compared to traditional chatbot approaches. Code generation represents one of the most transformative applications of LLMs for knowledge workers. Models like GitHub Copilot, Claude, and GPT can write complete functions from natural language descriptions, explain existing code, identify and fix bugs, generate unit tests, and translate code between programming languages. Studies of developer productivity with AI code assistants consistently show significant reductions in time spent on routine coding tasks, allowing engineers to focus on higher-level architecture and problem-solving. Document summarization addresses one of the most time-consuming knowledge work tasks, extracting the key points from long reports, legal contracts, research papers, and meeting transcripts. LLMs can process documents of thousands of words and produce accurate, coherent summaries that capture the essential information. In legal, financial, and research contexts, this capability alone represents enormous productivity gains, enabling professionals to process far more information than would be possible through manual reading alone. Content creation at scale is now accessible to organizations that previously lacked the writing resources to produce large volumes of high-quality text. LLMs can draft blog articles, product descriptions, marketing emails, social media content, and structured business reports from briefs or outlines. While human review and editing remain important for quality control, LLMs dramatically accelerate the drafting phase and can adapt tone, style, and vocabulary to match specific brand guidelines or audience profiles. Let us bring together the essential points from our exploration of large language models. To explore more key concepts in generative AI, check the link in the description. If you found this helpful, please like and subscribe. Thank you for watching. If you found this helpful, please like and subscribe. See you in the next video.